Here's some information that I learned over my 3.5 years of dealing with people online concerning new theory development. Rule number 1. Do not respond to people who just want to instigate. Their motives are sometimes not clear. They're a huge time sink. I actually dealt with one on the thunderbolts.info forum, and it took a lot out of me just to respond and try to make it into a cohesive conversation about a lot of things, but I just learned that there was something mentally disturbed with that person. So your best option is to, if you see somebody who's mentally incapacitated or is probably drunk or high or something on the other end of the conversation, because you don't know, you just see words, try to ignore it because it's a huge time sink. It's going to waste your time. Number 2, if you have a new idea, publish it onto Vixra and explain it to the best of your ability. More times than not, you have an idea which everybody believes to be true, which is probably actually completely false. And you can see that, and I think the world should know about that idea and publish it in a way where everybody can understand it when they read it, and it doesn't have any grammar issues, and it can be understood by a large majority of people regardless of what your field of study is in. A lot of those ideas are very creative, and there are some things in there that need to be investigated some more. Number 3, do not worry about name calling. It's just their insecurities. People are insecure. They don't like to believe that their ideas are, obsolete or whatever, because it hurts their feelings. So don't worry about name calling. It's something that, comes and goes. Number 4, for God's sake, read physics and chemistry books. You have to read those things, man. You have to look at them. Try to understand everything that's in there. And most importantly, do what they never taught me in college. Look for inconsistencies. Look for things that are not clearly explained. They don't know everything, man. If you can find inconsistencies in things that are not clearly explained, chances are there's a huge discovery to be made right underneath the surface. It's right there, staring at you in the face. They're easy to find. When you have contradictions in physics and chemistry textbooks, you have discoveries. Plainly put. Look for math dodges. Math dodges are quite common in physics books these days. They put math there as if it's some type of mechanical explanation, but it's not. It's just a math dodge. They say, look at the math formula. Don't pay attention to the fact that we don't know what we're doing. Go look over there. Look over there. A good example of that is what's called quantum mechanics. Quantum mechanics has no mechanics. It's a mathematical formulation of things. They have no mechanics. It's like calling Iceland and Greenland, giving them those names. But Iceland is green, and Greenland is full of ice. Quantum mechanics has no mechanics. Maybe Greenland used to have lots of green in it, but like quantum mechanics, it used to have mechanics in it, but it doesn't anymore. It's just mathematical nonsense. It's garbage. As well, when you look at physics and chemistry textbooks, look for clear cause and effect things. The past, the quantum people, they tried to ignore cause and effect. They thought it wasn't all that important, so they tried to ignore it. So the mentality spread like a virus throughout the physics community, and there are a lot of people in those fields of study that think that they're actually studying something, but no, they don't have any cause and effect for what they're hypothesizing. There's always cause and effect. As well, try to synthesize phenomenon. Now, a conceptual basis for this is nature is not disconnected. I don't mean everything is connected literally. I mean nature is not disconnected in the way that, oh, if a tree grows over here, then chances are, it's completely isolated from the environment. No, it has roots in the ground, obviously. A more physics definition or example would be electricity and magnetism. They're both interconnected. If you have electrical current, you have a magnetic field around it. It's not disconnected. And be creative. Try to turn those ideas upside down inside of physics textbooks and chemistry textbooks. Don't look at what they have to say and take it literal and think that it's all figured out. No, chances are there are discoveries to be made if you can just think about the problems that they show you in a creative fashion. As well, for the second part of this, I've studied establishment people and how they treat others online, and they have a few things in common that I want to share with you guys as well. A mentality they have is they think it's all figured out, and the basics are already known. The science is settled. No, it's not. Not even close. They don't even know what the Earth is. They don't even know what they're standing on. The fact that it's an ancient star at the end of its evolution. They don't even know that. They don't know what causes gravitation. They don't know what causes magnetism. They don't know what causes radioactivity. They essentially don't know any of the basics. This is very, very bad. It means if you have the mentality that science is settled, that you just clearly want to remain ignorant concerning nature, and you're happy with your little bubble of reality. It doesn't mean that science is settled, and it also doesn't mean that you understand the basics. They're arrogant, obviously, because they have their degrees and they think they know everything. Chances are they know very little. So you have to treat them as the arrogant fools that they are. You have to let them have their say and pay attention to what they say, and then try to take a step back and synthesize their little arrogant bubbles together to make something that's actually cohesive. They tend to be frightened of ideas which step out of the bounds of what they were taught in school. If frightened, if not paranoid about new ideas that step out of bounds with what they were taught in school. They're outright paranoid of them. They're afraid of them. Like, oh no, what if what I was taught in school is all wrong? They don't like that idea. It makes them uncomfortable. So when they see a new idea, they'll ridicule you and tell you how dumb you are, or how much of a crank or crackpot you are. Just ignore it. They don't have the mental capacity to handle new creative ideas. Remember, they were conditioned into a system to be to be smart enough to run the machines and do the math equations, but not smart enough to question the root assumptions of their parent organization and to question their position and what they were told in school. As well, most of these people, they don't speak up because they think making mistakes is a bad thing. The school system conditions them to believe that making mistakes is bad. Literally. That's what the A, B, C, D, F system is. It says, don't make any mistakes, do everything perfectly, that way you can get your A and move on. They get conditioned to that through elementary school, middle school, high school, college. That's the mentality they have. So naturally, when they go out into the real world, making mistakes is a bad thing. But that's kind of a catch, because how is it you're supposed to make progress and to work on new things if you never make any mistakes? How are you supposed to learn anything if there are no mistakes being made? Think about it. If you do everything perfectly, you're not doing anything new. You're doing the old stuff. You're not making any progress at all. So basically, that's my little spiel here. Hopefully people can take this understanding and make the most of it. Maybe they'll learn something that I didn't learn and share with the world. Alright, today is April 15th, 2015.